everyone, hope you all are doing good. I am Anjana from LearnoHub, the free learning platform where you can study math, science and SST absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 9 Physics Chapter 2 Motion in One Dimension. We will discuss the last topic, Equations of Motion, and solve questions from exercise 2C. Hope you all are ready for the session. Let's begin. Equations of uniformly accelerated motion. So, the starting of this chapter, we have discussed very important terms. We studied what is distance, displacement, speed, velocity, uniform motion, acceleration, negative acceleration, deceleration or retardation, and the uniformly accelerated motion. We have also discussed the graphs, okay, for different motions, that is uniform motion, uniformly accelerated motion for body at rest. We have studied the displacement time graph or position time graph, velocity time graph and acceleration time graph. So, here we are going to discuss the very important three equations of motions. Okay. So, here when you consider a body that is moving with an initial velocity u who is in uniform accelerated motion. Okay. Uniform accelerated motion means the motion of the body is under uniform acceleration or the acceleration value is a constant. So, in time t its velocity changes to v and it has travelled a distance of s. Okay. So, in that case, the first equation of motion is v is equal to u plus at. So, v is the final velocity, u is initial velocity, a is the acceleration and t is the time. So, when u is in meter per second, v is also in meter per second, time will be in seconds and distance will be in meters, acceleration will be in meter per second square. Okay. If initial velocity is in kilometer per hour, then final velocity will also be in kilometer per hour, time will be in hours, distance will be in kilometer and acceleration will be in kilometer per hour square. Okay. If we have the velocity in kilometer per hour, we know how to convert it into meter per second. What should be done? We have to multiply with 5 by 18. Okay. If the velocity in meter per second to be converted to kilometer per hour, in that case multiply with the reciprocal which is 18 by 5. These are just the basic things. Okay. Now the second equation of motion is s is equal to ut plus half at square, where s is the distance travelled or distance covered or displacement, u is the initial velocity, t is time and a is acceleration. And the third one is v square is equal to u square plus 2as, where v is the final velocity, u is the initial velocity, a is acceleration, s is the distance covered. So, this can also be written as v square minus u square is equal to 2as. Both are correct. Okay. So, we need this important equations to solve questions that are related to this. First, we are going to derive the first equation of motion, which is v is equal to u plus at. So, here you can see a graph that is plotted for uniformly accelerated motion under a velocity time graph. So, we have discussed the different graphs, position time graph, velocity time graph, acceleration time graph. So, when a body is in uniform accelerated motion, then you will be getting the position time graph. This will be somewhat like this. Okay, this will be how the position time graph will be. Okay, xt. When it comes to velocity time graph, you will be having a graph that is inclined or plot a line that is inclined to the time axis or x-axis. Okay. Now, when you draw a graph for uniformly accelerated motion, an acceleration time graph, okay, then you will be getting acceleration value to be same. Therefore, a line that is parallel to the time axis or x-axis. Okay. Now, we have a velocity. What is the velocity time graph? Time is along the x-axis and velocity is along the y-axis. Okay. So, here we are taking velocity in meter per second and time in seconds. Okay. Now, here t is the total time taken, initial velocity is u and final velocity is v. So, this AB line shows the uniformly accelerated motion, okay, from u velocity to v velocity in time t. Okay. Now, we know that the displacement time graph, from a displacement time graph, we will be getting velocity. How to get? Velocity is the slope of displacement time graph or position time graph. Similarly, acceleration is the slope of velocity time graph. Okay, acceleration is the slope of velocity time graph. So, slope is equal to acceleration. So, if you have this idea, you can easily do the derivation. So, here what is slope? Slope will be equal to, slope of AB will be equal to BE divided by AE. What is BE? BE is CA. CA divided by AE. This part is equal to OD. Okay. Now, here you can see CA. CO is total is V and AO is U. Okay. We have CA is equal to, how do we get CA? CA will be equal to CO minus AO. Okay. That is CO minus AO divided by OD. Okay. What is CO? Final velocity V minus AO is initial velocity U and OD is the time T. Okay. Therefore, slope will give you the acceleration. Acceleration A is equal to V minus U divided by T. Taking this T to the opposite side, AT is equal to V minus U, or V is equal to, taking negative U to the opposite side, that is U plus AT. Okay. V is equal to U plus AT. So, this is the first equation of motion which we have derived from the velocity time graph for uniformly accelerated motion. So, we have an alternate method to derive the first equation of motion. By definition, we know that acceleration is equal to, acceleration is change in velocity by time. Without using graph, we are going to derive change in velocity divided by time. So, here acceleration will be, what is change in velocity? Final velocity minus initial velocity, V minus U by T, taking T to the opposite side, same steps, AT is equal to V minus U and V is equal to U plus AT. So, this is also correct. So, this is a simple derivation. Okay. So, derivation using the velocity time graph and the derivation by just the definition of acceleration. Okay, this is an alternate method. Now, let us derive the second equation of motion, which is S is equal to ut plus half at square. So, here we are using the velocity time graph to find the distance. Okay, we have studied that from a velocity time graph, displacement can be determined. How? Area under a velocity time graph gives you the displacement. Okay, therefore, distance covered will be equal to area of. So, here this is the region that we need to consider. Okay. So, area under the trapezium, area of trapezium OABD. Okay. Area of trapezium OABD. Now, you can see that this trapezium is made up of a rectangle and a triangle. So, this can be written as area of rectangle AEDO plus area of triangle BEA. Now, how to find the area of rectangle? Area of rectangle is length into breadth. So, here we have the length OD. OD into breadth OA. Plus, what is the area of triangle? Half into base into height. Here, base is equal to AE and height is equal to BE. Okay. So, here this is equal to OD into OA plus half into AE will be equal to OD. Yes. So, this is OD into BE will be equal to CA. That is equal to OD is T and OA is U. T into U plus half into OD is again T. What about CA? CA will be equal to V minus U into V minus U. So, we are getting UT plus half into V minus U into T is the distance covered S. So, we are almost reached, but here we have V minus U, but here it is A. Now we have to change this v minus u to a, and the time, here we have just t, here we have t square. So we have the first equation of motion, that is v is equal to u plus at, which means v minus u will be equal to at. Here we have v minus u. In place of v minus u, we can substitute at. Then this becomes ut plus half at into t, that is ut plus half at square. Okay, ut plus half at square. Okay, so this is the derivation of the second equation of motion using the graph, okay, velocity time graph. Now we need to study the alternate method. So we have the average velocity. Average velocity is equal to u plus v divided by 2. And the distance covered is always equal to, distance covered is average velocity into time. Okay, here average velocity is u plus v by 2 into t. Okay, and distance covered is s. So s is equal to u plus v by 2 into t. So from the first equation of motion, we have v is equal to u plus at. So this v, in place of v, I am substituting u plus at divided by 2 into t. U plus u is 2u plus at divided by 2 into t. Okay, so this becomes equal to 2u into t divided by 2. That is, I am removing the brackets and multiplying, plus at into t is at square divided by 2. 2 gets cancelled, then you have ut plus half at square. Okay, s is equal to ut plus half at square. So we have derived the second equation of motion directly. Next, derivation of v square is equal to u square plus 2as. Here again, we have distance covered is equal to, distance is equal to area of trapezium OABD. Okay, so what is the area of trapezium? Half into the sum of parallel sides. Okay, here OA is parallel to BD. Therefore, OA plus BD into the base, that is OD, which is equal to half into OA is equal to U plus BD is equal to V and OD is equal to T. Okay, so here you can see that in this equation we don't want T. Okay, so we have to remove this T. First equation of motion we have V is equal to U plus AT, from which what is T? V minus U is equal to AT and T is equal to V minus U divided by A. V minus U by A. So in place of T, I am going to put V minus U divided by A. That is equal to half into U plus V into V minus U divided by A, or V minus U into V plus U divided by 2A is the S. Distance S is equal to V minus U into V plus U divided by 2A. So V minus U into V plus U is V square minus U square divided by 2A. S is equal to V square minus U square divided by 2A, from which we will be having, taking this 2A to the opposite side, 2AS is equal to V square minus U square, then V square is equal to U square plus 2AS. Okay, V square is equal to U square plus 2AS. So this is how we can derive the third equation of motion from the velocity time graph of a uniformly accelerated motion. Now the direct method, same steps, will start with the same steps for the second equation of motion. Distance S is equal to average velocity into time. Average velocity into time. So what is average velocity? U plus V divided by 2 into time t. Here again, in the third equation of motion, we don't have time, we have to change time. What is time? Time is V minus U by A. So in place of t, we put V minus U divided by A. Okay, so S is equal to U plus V by 2, V minus U divided by A, and that is V square minus U square divided by 2A. Okay, S is equal to V square minus U square by 2A. 2AS is V square minus U square, or V square is equal to U square plus 2AS. Okay, so the third equation of motion. Now consider a case, a body is initially at rest. When a body is initially at rest, what is the initial velocity? Initial velocity U will be equal to 0. Then we can rewrite all these three equations of motion. First equation is V is equal to U plus AT. When U becomes equal to 0, then V is equal to AT. Okay. Now the second equation, all these three equations we have U, right? So S is equal to UT plus half AT square. When U becomes equal to 0, S is equal to UT plus half AT square. S is equal to 0 into T plus half AT square. 0 into T is 0. 0 plus half AT square. So S is equal to half AT square. Okay. So the second equation changes to this when U becomes equal to 0. Now the third equation, V square is equal to U square plus 2AS. When U becomes equal to 0, then V square is equal to 2AS. If you are asked to find acceleration, then acceleration is V square divided by 2S. If you are asked to find the distance, S is equal to V square divided by 2A. So this is the third equation of motion when the initial velocity becomes equal to 0. Now when a body is moving with uniform retardation, we know what is retardation. Retardation is negative acceleration. In that case, the final velocity will be less than the initial velocity. Applying brakes and the body is coming to rest in time t. In that case, we know that the velocity, final velocity will be less than the initial velocity. This is a case of retardation. Okay, so in that case what happens? We have studied the acceleration will be a negative value. Acceleration A will be negative. Okay, so in all these three equations, A becomes negative. V is equal to U plus minus A into T, which is V is equal to U minus AT. Second equation, S is equal to UT plus half into minus A into T square, which is equal to UT minus half AT square. S is equal to UT minus half AT square. Third equation of motion, V square is equal to U square plus 2AS. So here V square is equal to U square plus 2 into minus A into S. V square is equal to U square minus 2AS. So this is the third equation of motion. So this is how the three equations of motion changes when the body is undergoing retardation or having a negative acceleration. A is equal to negative. Let us take an example. A car acquires a velocity of 72 km per hour in 10 seconds starting from rest. Calculate the acceleration, the average velocity and the distance travelled in this time. So here the car is starting from rest, which means the initial velocity will be equal to 0. Initial velocity U is equal to 0. Now final velocity is given. Final velocity V is equal to 72 km per hour. So here velocity is in kilometer per hour and time taken is given in seconds. So either we have to convert the seconds to hour or this kilometer per hour to meter per second. So what is 1 kilometer per hour? In meter per second, 1 kilometer per hour will be equal to 1 kilometer we know. This is 1 kilometer divided by 1 hour. Okay, what is 1 kilometers in meters? It is 1000 meters. So 1000 meters divided by, what about 1 hour? 1 hour is 60 minutes and 1 minute is 60 seconds. So 1 hour will be equal to 3618 into 2 is 36. So this is equal to 5 by 18 meter per second. So 1 kilometer per hour is equal to 5 by 18 meter per second. Or if you need to convert meter per second into kilometer per hour, what can be done? We'll take this reciprocal. Taking this to the opposite side, it becomes a reciprocal. Then 1 meter per second is equal to 18 by 5 kilometer per hour. So here We have 72 km per hour, which is equal to 72 into 5 by 18 meter per second. So 18 into 4 is 72. So you will be getting the final answer 20 meter per second. Okay, what else is given? Time is given. Time t is equal to 10 seconds. So first we are going to calculate the acceleration. How to find acceleration? We have acceleration A is equal to v minus u divided by t. Substitute the values. 20 minus 0 divided by time t is 10 seconds. So this is 2 unit is meter per second square. Okay. Now the second part of the question, we have to find the average velocity. What about average velocity? Average velocity, let's take capital V, will be equal to initial velocity plus final velocity V divided by 2. Okay. Here initial is 0, final is 20 divided by 2. Therefore, you will be getting 10 meter per second. Okay. So, average velocity is 10 meter per second. Now, the third part of question we need to find distance travelled. So, how to find distance travelled? We have formula. S is equal to ut plus half at square. This is the second equation of motion which we have discussed. Okay, here S is the distance, u is initial velocity, t time, a acceleration. Okay, now put the values. S is equal to 0 into 10 plus half into acceleration we have determined, which is equal to 2, t square. Time we have determined, which is 10 square. So this part becomes 0, 2 gets cancelled, plus 10 square 100. Therefore, S is equal to 100 meters. Okay, either you can find like this, or we have distance is equal to average velocity into time. So here what is the average velocity? 10 meter per second into time is 10. So 10 into 10, 100 meters. Okay, better you can use this formula, that is the equation of motion, to find. Clear? Example 2, a ball is initially moving with a velocity 0.5 meter per second. Its velocity decreases at a rate of 0.05 meter per second square. How much time will it take to stop? Second, how much distance will the ball travel before it stops? So, what are the quantities given? Here we are given the initial velocity, which is 0.5 meter per second. Initial velocity u is equal to 0.5 meter per second. Okay, now its velocity decreases, which means here retardation is happening, deceleration or negative acceleration is happening at a rate of 0.05 meter per second square. What does it mean? It means that the acceleration value will be negative. Acceleration A will be minus 0.05 meter per second square. Now, A part of the question, how much time will it take to stop? So, since it is coming to stop, we'll be having final velocity v is equal to 0. Okay, we have to find the time. Okay, now check all the three equations. Here we have, you take the equations. The first equation is v is equal to u plus at, s is equal to ut plus half at square, v square is equal to u square plus 2as. So here what we need to find? We need to find the time. In the third equation, there is no time, so it cannot be considered. Take the first and second. Okay, now check what are the quantities given. Only one quantity should be unknown. Here, time we are finding, therefore time should be unknown. In the first equation, if you check, we know the value of v, then you want the value of u, we know the value of u, then you need a value is also known. If you are considering the second equation, then we need s. We don't know what is s. First, we will have to determine what is s and only then substitute. So, better to use the first equation of motion. So, we have to find time. We have v is equal to u plus at. Okay. From which we can write at is equal to v minus u and t is equal to v minus u divided by a. So, here v is 0 minus u is equal to 0.5 divided by acceleration minus 0.05. Okay. So which is equal to, negative signs gets cancelled, 0.5 divided by 0.05, which can be written as 50 divided by 5, or that is 10 seconds. Okay. So time taken is 10 seconds. Now the B part of question, we have to find how much distance will the ball travel before it stops. So distance to find, we have S is equal to ut plus half at square is the first formula. Then v square is equal to u square plus 2as. Okay. Either of these formulas can be taken. So here if you take this, you have the value of initial velocity, time is not, acceleration is not. Okay. When you consider the second equation, we know the value of v, we know the value of u, also we know the value of a. Okay. So now I am going to take the second equation. Then what is S? S will be equal to v square minus u square by 2a. Here v square will be equal to 0 square, which is 0, minus u square will be equal to 0.5 square divided by 2 into acceleration is minus 0.05, which is equal to minus 0.5 into 0.5 divided by 2 into minus 0.05, which is equal to, negative signs can be cancelled, 0.5 into 0.5 divided by 2 into 0.05 is 0.1. Okay. So numerator, what do we get? You will be getting 0.25 divided by 0.1, which will be equal to 2.5 meters. Okay. Here the distance travel will be 2.5 meters. Clear? Example 3, a car initially at rest starts moving with a constant acceleration of 0.5 meter per second square and travels a distance of 25 meter. Find its final velocity and the time taken. So here given that a car is initially at rest, which means u is equal to 0. Okay, constant acceleration is given, which is 0.5 meter per second square. Distance travelled is given, S is equal to 25 meter. So first part of the question, we need to find its final velocity. How to find final velocity? We have v is equal to u plus at, but we cannot use this. Why? Here we are going to find final velocity, but we don't know what time is. Okay, so this cannot be taken. Then next is v square is equal to u square plus 2as. How about this? Can we use this? Yes, right? Why? Because we know the value of u, we know what a is, and we know what s is. So this is what this equation we are going to take. That is the third equation of motion. So v square will be equal to u square, which is 0 square, plus 2 into 0.5 into a, s, which is 25. Okay. So v square is equal to 0 square can be removed. Then 2 into 0.5 is 1. Then you have 25. So v is equal to root of 25. Root of 25, we have two values, positive 5 and negative 5. Here we cannot take negative 5. Why? Because this is velocity. Velocity can never have negative values. Okay, that is, we will be getting positive 5 meter per second. Okay, direction can be opposite, which means then the negative can be considered. But here it is 5 meter per second, which is the final velocity. Now the second part of question, we have to find the time taken. So how to find time taken? We have v is equal to u plus at. Here v is 5, u is equal to 0 plus acceleration 0.5 into time t. Okay. So 5 is equal to 0.5 t and t is equal to 5 by 0.5, which is equal to 10. 10 seconds is the time taken. Example 4, a body moving with uniform acceleration travels 84 meter in the first 6 seconds and 180 meter in the next 5 seconds. Find the initial velocity and acceleration of the body. So here, let u be initial velocity and a be the acceleration. Okay. So a body moving with uniform acceleration travels 84 meter in the first 6 seconds. So we'll take the first distance as S1. S1 is equal to 84 meter and the first time is T1, which is 6 seconds. Okay, and 180 meter in the next 5 seconds. So what is the total distance that we'll take as S2? S2 will be equal to 180 plus 84, which is equal to 264. Okay, and T2 is equal to 6 seconds plus 5 seconds, which is 11 seconds. Okay. Now we have to find the initial velocity. So let's consider the equation. S is equal to ut plus half at square. Okay. So here we have used this equation because there should be a relation that shows distance traveled and time taken. So this is the equation. And it also contains acceleration and final velocity, which we have to determine. Okay. So S1 will be equal to ut1 plus half at1 square. Now put the value. S1 is 84 is equal to u into T1 is 6 plus half into A into 6 square, which is 84 is equal to 6u plus 6 square is 36. 36 divided by 2, you will be getting 18a, or 84 is equal to 6 is common, u plus 3a. Okay, so u plus 3a is equal to 84 divided by 6, which is 14. Okay, so u plus 3a is equal to 14. Let us take this as equation 1. Now, to get the second equation, we have S2 is equal to ut2 plus half at2 square. S2, here S2 is 264 is equal to u value, we don't know. Time is 11 plus half a 11 square. Okay, so 11 is common. Taking out 11, u plus a by 2, 11a by 2 is equal to 264. So 264 by 11 is equal to u plus 11a divided by 2. So this becomes 24. So u plus 11a by 2 is equal to 24. So from the first equation, you will be having u is equal to 14 minus 3a. Okay, substituting in the second equation. This is second equation. So u is equal to 14 minus 3a plus 11a by 2 is equal to 24. Taking LCM. So here you can see these are a containing terms. So the term which doesn't contain a taken to the opposite side. Okay, this becomes 11a by 2 minus 3a is equal to 24 minus 14, which is equal to 10. So here denominator 2, 11a minus 6a. What is 11a minus 6a? We get 5a. So 5a is equal to, taking this 2 to the opposite side, it is 20. And a is equal to 4 meter per second square. Okay, now we'll substitute the a value in this equation to find what u is. So u will be equal to 14 minus 3 into 4, which is 14 minus 12, and that is equal to 2 meter per second. So the initial velocity is 2 meter per second and acceleration is 4 meter per second square. So this is the answer to first question, that is A part, and this is the answer to B part. Clear? Example 5, a particle starts to move in a straight line from a point with velocity 10 meter per second and acceleration minus 2.0 meter per second square. Find the position and velocity of the particle at t is equal to 5 seconds, t is equal to 10 seconds. Here what is given? We are given with the initial velocity u, which is equal to 10 meter per second, And acceleration, here this is a case of retardation, a is equal to minus 2.0 meter per second square. We have to find the position, which means the distance, and we have to find the final velocity at two different times. So first we will be finding at t is equal to 5 seconds. So to find the velocity and the displacement, which equation can be used? Using the equation v is equal to u plus at. So using this we can find the velocity. Now to find the distance traveled, which equation can be used? If you use s is equal to ut plus half at square, here we have u, a and t. Okay. Then after you find, you have determined what v is, you can use the other equation, v square is equal to u square plus 2as. So both are correct. Okay. Now we'll use this to find what v is. Okay. So v is equal to 10 plus minus 2 into 5, which is equal to 10 minus 10, that is 0. So final velocity after, that is the velocity after a time 5 seconds is equal to 0. Now we'll find what the distance travelled s is. S is equal to ut plus half at square. So here s is equal to 10 into 5 plus half into minus 2 into t square. T square is 5 square, which is equal to 10 into 5 is 50. 2 and minus 2 cancel, minus 1. So minus 5 square, 25. So you will be getting 25 meters. So 25 meters is at 25 meters from the starting point. It is at a distance of 25 meters. Now the second part we have to find when time t is equal to 10 seconds. So v is equal to again u plus at. V is equal to, u will be same 10 plus a will be same minus 2. Just the time will change, it becomes 10. So 10 minus 20, which is equal to minus 10 meter per second, which means it is in the opposite direction. Okay. Next we have to find what s is. S is equal to ut. Here 10 into 10 plus half into acceleration minus 2 into t square, that is 10 square, which is equal to 10 into 10, 100. 2 and minus 2 cancel, minus 1. So minus 100, that is 0. So the total distance travelled or the displacement will be equal to 0 meters. Example 6, a particle initially at rest moves with an acceleration 5 meter per second square for 5 seconds. Find the distance travelled in 4 seconds, 5 seconds and 5th second. So what is the difference between 5 seconds and 5th second? So 5th second means we have to subtract the distance travelled in 4 seconds from the total distance travelled in 5 seconds. Okay. So first we will find for 4 seconds. So particle is initially at rest, which means u will be equal to 0. Acceleration is given, which is 5 meter per second square, and time is given, which is 5 seconds. So we have to find the distance travelled. S is equal to ut plus half a t square. So when a part of the question, t is equal to 4 seconds, s will be equal to 0 into 4 plus half into 5 into 4 square, which is equal to, so here this is 0 plus half into 5 into 4 into 4, cancelling, here it becomes 2, 4 into 2 is 8, 8 into 5, 40. So 40 meters is the total distance travelled when the time is 4 seconds. Now when the time becomes, B part of the question, when time becomes 5 seconds, again S is equal to ut plus half a t square, which is equal to 0 into 5 plus half into a is equal to 5 and t square is 5 square. That is, this part again 0 plus 5 square is 25. 25 into 5 is 125. 125 divided by 2, which is equal to, you will be getting 62.5 meters. Okay. Now the distance travelled in the 5th second. C part, distance travelled in fifth second is equal to distance travelled in 5 seconds minus distance travelled in 4 seconds. That is equal to 62.5 minus 40, which is 22.5 meters. So, here it is moving a distance of 22.5 meters in the 5th second. Clear? Now, let us solve questions from exercise 2C. Question 1 of exercise 2C. A body starts from rest with a uniform acceleration of 2 meter per second square. Find the distance covered by the body in 2 seconds. So, here we are given that the body starts from rest, which means the initial velocity u is equal to 0. Then acceleration a is given, which is 2 meter per second square. Time is given 2 seconds. We need to find the distance covered. So, S is equal to ut plus half a t square. S is equal to 0 into 2 plus half into 2 into 2 square. Okay, 2 gets cancelled, then you will be getting 4 meter. So, here the distance covered is equal to, or distance travelled is equal to 4 meters. Very simple, right? You are directly given the values. You have to substitute in the second equation of motion. Question 3 of exercise 2C. A vehicle is accelerating on a straight road. Its velocity at any instant is 30 km per hour. After 2 seconds, it is 33.6 km per hour. And after further 2 seconds, it is 37.2 km per hour. Find the acceleration of vehicle in meter per second square. Is the acceleration uniform? So, here we have 2 cases. Okay. So, first case, when the initial velocity u is equal to 30 km per hour, time is 2 seconds and the final velocity is 33.6 km per hour. How to find acceleration? Acceleration will be v minus u divided by t. So, here you can see time is in seconds and the initial and final velocities are given in kilometer per hour. So, first we need to convert it into meter per second, kilometer per hour to meter per second into 5 by 18. So, here again into 5 by 18. Okay. When you do, you will be getting this in meter per second. So, this is 33.6 into 5 by 18 minus 30 into 5 by 18 divided by time, that is 2 seconds. So, 5 by 18 is common, taking out 33.6 minus 30. Okay. Divided by 2, that is equal to 5 by 18 into 33.6 minus 30, you will be getting 3.6 divided by 2, that is equal to 18, 3.6. How much do we get? This is 0.2. 5 into 0.2. What is 5 into 0.2? 5 into 2 is 10. Then you have a point. So, 1. 1 by 2, which is equal to 0.5 meter per second square. So, here we are getting 0.5 meter per second square. Now, this case 2, second case. In the second case, the initial velocity u is equal to 33.6 km per hour, which is 33.6 into 5 by 18 meter per second. The final velocity v is equal to 37.2 km per hour, which is 37.2 into 5 by 18 meter per second. Okay, here again the time is 2 seconds. Time 2 seconds. Then acceleration is equal to 5 by 18 is common. 37.2 minus 33.6 whole divided by 2, which is equal to 5 by 18 into. So, here you will be getting 3.6 again divided by 2, cancelling. This is 0.2, again 1 by 2, which is 0.5 meter per second square. So here you can see that the acceleration in the first case and acceleration in the second case is same, which is 0.5 meter per second square, from which we can conclude that same acceleration, constant acceleration. Therefore, is the acceleration uniform? Yes, this is an example of uniform acceleration. The answer is yes. Clear? Question 5 of exercise 2C. A bullet initially moving with a velocity 20 meter per second strikes a target and comes to rest after penetrating a distance 10 centimeter in the target. Calculate the retardation caused by the target. So here the initial velocity u is given, which is equal to 20 meter per second. It comes to rest, which means final velocity v is equal to 0. Distance is given, s is 10 centimeters. So first we have to convert this 10 centimeters into meters. What is 10 centimeters in meters? We have 1 meter is equal to 100 centimeter. Yes, 1 meter is 100 centimeter, which means 1 centimeter will be 1 by 100 meters. Therefore, 10 centimeter will be 10 by 100 meters, or that is equal to 0.1 meters. So we get 0.1 meters. We need to find what acceleration is. We have v square is equal to u square plus 2as, third equation of motion. So using this, you are going to find what the value of a is. So we have 2as is equal to v square minus u square, and a will be equal to v square minus u square divided by 2 into s. Okay, put the values. V is 0, 0 square minus u is 20, 20 square divided by 2 into 0.1, which is equal to 0 minus 400 divided by 2 into 0.1, which is equal to 0.2. We get minus 400 divided by 0.2. So removing decimal, that is minus 4000 divided by 2, which is minus 2000. So acceleration is minus 2000 meter per second square. Then what about retardation? Retardation is equal to 2000 meter per second square. 2000 meter per second square is the retardation. Question 9 of exercise 2C. A car travels a distance 100 meters with a constant acceleration and average velocity of 20 meter per second. The final velocity acquired by the car is 25 meter per second. Find the initial velocity and the acceleration of the car. Okay, so here we are given the distance is equal to 100 meters. Average velocity is given. Average velocity is equal to 20 meter per second, and final velocity is given, which is 25 meter per second. Okay. First part of the question, we need to find the initial velocity u. How to find initial velocity? We have average velocity given. Yes. Average velocity will be equal to u plus v divided by 2, initial velocity plus final velocity divided by 2. Here initial velocity we need to find. We know what average velocity is, which is 20 plus 25 by 2. Okay. Therefore, u will be equal to, here 20 into 2. 20 into 2. This 25 taken to the opposite side, minus 25, which is equal to 20 into 2, 40 minus 25, that is 15 meter per second is the initial velocity. Initial velocity is equal to 15 meter per second. So the second part of the question, we need to find what acceleration is. Okay, so how to find acceleration? Which equation to use? So here we know what s is. We have v value, we have u value. Time is not given. Neither acceleration is also not given. We have to find what acceleration is. Okay. So we have the relation v square is equal to u square plus 2as. 2as is equal to v square minus u square, and a is equal to v square minus u square divided by 2s. That is v square 25 square minus u square. 15 square divided by 2 into s. S is equal to 100 meters. 2 into 100. Which is equal to, what is 25 square? 25 square is 625. 15 square is 225 divided by 200. That is equal to 625 minus 225, you will be getting 400 by 200, which is 2 meter per second square. Okay, so 2 meter per second square is the acceleration. Question 10 of exercise 2C. When brakes are applied to a bus, the retardation produced is 25 centimeter per second square and the bus takes 20 seconds to stop. Calculate the initial velocity of the bus and the distance travelled by bus during this time. So here, for the first part of question, we need to find what is initial velocity. We are given that the retardation produced is 25 centimeter per second square, which means the acceleration will be minus 25 centimeter per second square. So we have to convert this into meter per second square. What can be done? Here we have 25 centimeters. Converting to meters, we have to divide by 100. Okay, this is minus 25 by 100 meter per second square. Okay, time taken t is given, that is 20 seconds. So to find the initial velocity, how to find the initial velocity? Which equation can be used? So here, applying brakes, the body is coming to rest. Okay, it comes to stop, which means V value will be equal to 0. Okay, now we can find the initial velocity. Yes, using which equation? V is equal to U plus A into T. So U will be equal to V minus AT. That is 0 minus acceleration minus 25 divided by 100 into time is 20. Okay, 20 and 100 cancels, you get 5. So this is minus of minus 5. So cancelling this, here we get 5, which is plus 5. Plus 5 meter per second is the initial velocity. Now we have to find the distance travelled by the bus in this time. S is equal to ut plus half a t square. Here S is equal to 5 into the time taken 20 plus half into acceleration a, which is minus 25 by 100 into time square, which is 20 square, 20 into 20. Okay. 5 into 20, that is 100. 2 and 20 cancelled, we get 10. Zeros can be removed. Then you have minus 25 into 2, which is minus 50. You will be getting 50 meters. So distance travelled is equal to 50 meters. Okay, so we have determined what the distance travelled and the initial velocity of the bus is. Question 13 of exercise 2. A car travels with a uniform velocity of 25 meter per second for 5 seconds. The brakes are applied and the car is uniformly retarded and comes to rest in further 10 seconds. Find the distance which the car travels before the brakes are applied. So how to find the distance? Distance is equal to speed into time. Here the velocity is given, which is 25 meter per second and time is 5 seconds. So the first part of the question, distance will be equal to speed into time. So here speed is 25 meter per second and time is 5 seconds. So that is equal to 125 meters. So distance is equal to 125 meters. Now the second part of the question, we have to find the retardation. Retardation. How to find retardation? Which equation to use? Take the values that are given. Brakes are applied and the car is uniformly retarded and comes to rest in further 10 seconds. So in 10 seconds, that is time 10 seconds, the body comes to rest. Final velocity is 0. What will be initial velocity? This value, u is equal to 25 meter per second. Okay, how to find the retardation? V is equal to u plus at. Use this, V is equal to u plus at and there A is equal to, AT is equal to V minus U, which implies A is equal to V minus U divided by T. Okay, V minus U divided by T. A is equal to V is 0 minus U 25 divided by time 10. Okay, which is equal to minus 2.5 meter per second square. So here you have to remember we are getting negative values. Why? Because this is retardation. Okay, final velocity will be less than the initial velocity. Okay, V less than U is a case for retardation. Okay, now the distance travelled by the car after applying the brakes. So before applying the brakes, the time taken is 5 seconds. After applying the brakes, the time taken should be 10 seconds. Okay, so third part of the question, how to find S. Okay, how to find S. That is S is equal to ut plus half at square. So here u is equal to 25, t is equal to 10 seconds plus half into acceleration minus 2.5 into t square, that is 10 square, which is equal to 25 into 10, 250, okay, minus 2.5 into 10 into 10 or 2.5 into 100. 2.5 into 10 is 25, 25 into 10 is 250, 250 divided by 2. Okay, so 250 minus 125, which is equal to 125 meters. So S distance is equal to 125 meters. The body travels a distance of 125 meters before coming to rest. That's all for today. In today's class, we have discussed the last topic of the chapter, motion in one dimension, which is equations of motion. We have discussed all the three equations. With graph, we have studied the derivation, also solved example questions from the textbook and questions from exercise 2C. Hope you all enjoyed the session. I'll be back in the next session. Until then, stay tuned to LearnoHub. LearnoHub free hai, par best hai. Thank you.